Let's compare the difference between a token bucket and a leaky bucket. A token bucket permits traffic to be bursty, but it bounds it by the rate rho. On the other hand, a leaky bucket simply forces the bursty traffic to be smoothed. The bound in a token bucket is as follows. If our bucket size is beta, then we know that in any interval t, then the rate is always less than beta, that is, the maximum number of tokens that can be accumulated in the bucket, plus the rate at which tokens accumulate times that time interval. We also know that the long-term rate will always be less than rho. Token buckets have no discard or priority policies, whereas leaky buckets typically implement priority policies for flows that exceed the smoothing rate. Both are relatively easy to implement, but the token bucket is a little bit more flexible since it has some additional parameters that we can use to configure burst size. One of the limitations of token buckets is the fact that in any traffic interval of length t, the flow can send beta plus t times rho tokens of data. If a network tries to police the flows by simply measuring their traffic over intervals of length t, the flow can cheat by sending this amount of data in each interval. Consider, for example, an interval of twice this length. Well, if the flow can send beta plus t times rho in each interval, then over 2t, the flow can consume 2 times beta plus tau times rho tokens. But actually, this is greater than how much the flow is actually supposed to be able to send, which is beta plus 2t times rho. So policing traffic being sent by token buckets is actually rather difficult. So token buckets allow for long bursts, and if the bursts are of high priority traffic, they are difficult to police and may interfere with other high priority traffic. So there's some need to limit how long a token bucket sender can monopolize the network.